Hello, good evening. Welcome to the third session of quantum mechanics. So, as we have discussed various issues, various concepts. Hello, good evening. Welcome to this session of quantum mechanics. So, already we have discussed various concepts related to quantum mechanics, wherein we have seen why there was a need for quantum mechanics and how quantum mechanics was developed eventually since 1900. So earlier to that, everybody knows there were classical mechanics, but still there is the existence of classical mechanics, and now we are moving with classical mechanics as well as the quantum mechanics. And when we discuss about quantum mechanics, then we always start or we always begin quantum mechanics from the concept of photoelectric effect. Then we move on towards the Compton effect, and then we move towards the de Broglie's hypothesis, and then like Heisenberg's uncertainty principle, Schrodinger's wave equation, WKB approximations, and so on. So in quantum mechanics, as we know, we are having the wave mechanics as well as the matrix mechanics, and both the mechanics are applicable to solve the means if we go for the higher order problem, then we go for the matrix mechanics. And if we are having the problem like hydrogen atom or the helium atom, and where as we know the system is not that much complicated to understand, so in that case we can apply the wave mechanics, and with the help of that we can get the solution for different problems arises in quantum mechanics with the help of Schrodinger independent and time dependent equations. So friends, these all things we will discuss in detail one by one. So as we have seen, we have discussed how quantum mechanics was developed and what are the learning objectives during this particular uh, session. So as already we have discussed the challenges of quantum mechanics along with the learning objectives in previous class. So now we'll be focusing on some of the more explanation towards the quantum mechanics. And when we talk about the quantum mechanics, then we are having one very typical or a very beautiful statement we called as small things are weird. And as we know about the small things, as Richard Feynman has given one lecture on, there is a plenty of rooms at the bottom, and you may be knowing from that particular lecture series there was a genesis or there was an invention of the nanomaterials, and again eventually nanomaterials or the field of nanomaterials also developed with the help of some of the devices which are based on the quantum mechanical phenomenon. You may be knowing that devices like scanning electron microscopy or the scanning tunneling electron microscopy and so on, like AFM and STEM and all like that. So friends, that is why we can say that the quantum mechanics is very much important to understand to means very much important to explain variety of phenomenon in physics. So, when we move again in deeper towards the quantum mechanics, then we are having certain views about quantum mechanics. So, the first thing that just I wanted to discuss here, like all matter or the particles has wave-like properties. What does it means? So, if we are saying if we are having some material or the matter, and if we are throwing it, then we are saying that there is association of the wave if particle is moving, and if like a wave is moving, then we can say that there is association of the particle, and that is what we called it as a wave particle duality. And that duality can be explained by using the de Broglie's hypothesis, where we know lambda is equal to h by p, or lambda is equal to h upon mv. So with the help of that we can give both the nature, one is the wave nature as well as the particle nature of the matter. And that has been proved with the help of like a Davison and Germer experiment. So that experiment proves the de Broglie hypothesis. So in that way, we have to think, we have to develop the concept of quantum mechanics so that we will be able to solve some numericals based on it. Then another concept, another most important concept in like a quantum mechanics is particle waves are described in a probabilistic manner. So the one thing everyone must remember in terms of quantum mechanics is the probabilistic mechanics. So we cannot say exactly like a position or the momentum of any of the microparticle. So we are using probabilistic man, or we are using the theory of probability to tell the position as well as the momentum. And accordingly we know electron doesn't whiz around the particle wave in a like a like a Okay, sorry for connection issue. So, friends, we were just trying to understand different things with the help of quantum mechanics. Like, means as we know, the electron cannot reside inside the nucleus. So, means then we can think how much probability is there to have electron inside the nucleus. So, answer means yeah, there may be, because nobody has given the explanation like exactly earlier to Heisenberg's, and then Heisenberg's had proved with the help of his famous principle, Heisenberg's uncertainty principle, that electron cannot reside inside the nucleus, and that gives again means allows for seemingly impossible like quantum tunneling. So if it cannot happen, then there should not be any way to have the quantum tunneling if electron. So means from that we can understand the things are very probabilistic. Then again, we can see here some properties come in dual packages. So can't know both simultaneously to arbitrary precisions. Means if we are just trying to understand the position and the momentum of a microparticle, then really it is difficult to know or to understand the exact position as well as momentum of a particle at the same time with exactness or simultaneously with exactness. But we can tell the position, first position then momentum, or first momentum then position, and that is always explained by the Heisenberg's uncertainty principle. So that is what, and again that principle is true if we are having the x-axis, then we can write it as a del x into delta px is greater than or equal to h by 2 pi, or the h cross. So likewise we can write this principle for energy and time. Delta e into delta t is greater than or equal to h cross, or h by 2 pi. So in that way, we can write and we can explain the Heisenberg's uncertainty principle. So again, we can see here the act of measurements fundamentally alters the system. So that is, you may be knowing about the entanglement, and recently some fellow has received the Nobel Prize for the quantum entanglement. So it's a very beautiful phenomena, and that gives again support to the quantum mechanics. so that information exchange alters the particle state. So that again, that supported as we know, so we have accepted it as a probabilistic mechanics, but there are certain experiments, there are certain theories that gives evidences for the truthfulness, or like a means for the applicability or for acceptability of the quantum mechanics. That is what the beauty of the quantum mechanics. Then again, we can see here some of the crises in physics that demanded quantum mechanics. So, like a crisis, so as simply you may be knowing, some scientists tried to understand the spectrum of black body radiation, and then they found with respect to temperature how spectrum were changing, and then they were trying to understand the physics behind it. So then they found yeah, what will happen with that and how it is happening and all. So why don't atom disintegrate in nanoscales? So again, as we know, means why the atom will won't get a disintegrate if we go for the nanoseconds. Then if electron is orbiting, it is then accelerating or wiggling. We call it as a wiggling. Charges emit electromagnetic radiations, and as we know, the electromagnetic radiation always begins from like a radio waves and end at a gamma radiations. And again, we know to every radiation there is an association of the energy, and that also explained with the help of quantum mechanics. E is equal to h nu. That is also one of the famous principle. With the help of that, we can explain the properties of electromagnetic radiations. So in that way, lot of theories supports to the quantum mechanics, and lot of quantum mechanical evidences supports to other mechanics for their existence. So in that way, we can say both are going in hand in hand. So that is why we cannot separate quantum mechanics from the classical mechanics, or classical mechanics from the quantum mechanics. Only thing is that when we move towards the quantum mechanics, then we can think about the microparticle. Whereas if we go for a classical mechanics or the Newtonian mechanics, then we think about the macroparticle. So that is the fundamental difference between two mechanics. And again, that gives us the explanation for these black body radiations. And as we know, if we are talking about black body radiations, then how energy will be emitted from any of the black body specifically, because as we know, the absorption of black body is ideally it is just like about 100%, but as we know, no body is perfectly black body. So that is again one of the concern. But again, there was we means scientists called it as a ultraviolet catastrophe. So when they tried to extend or explain the ultraviolet spectrum, then they found some anomaly in that particular spectrum, and then they yeah, they thought ki why it is so, why there is an anomaly, how it happens. So just they tried to understand, and then they have explained with the help of some quantum mechanical theories. So that is what the beauty of like a quantum mechanics. So the means the quantum mechanics could able to explain the phenomenon of the black body radiations and other phenomenon also. So again, here simply we can see pre-quantum mechanical problems like why was red light incapable of knocking the electrons out of certain materials, no matter how bright. So as we know, the red light cannot means cannot eject or knocking the electrons out from the certain materials, but the blue light could really do so even at modest intensities. So why it is happening? And then again, when they tried to understand the photoelectric effect, then they found how they found like we called as a threshold potential, and at what potential the electron can eject from the metal surfaces. And then for that, how much energy is required, and that is what you may be knowing about the E photon is equal to h nu. So in that way, like the explanation from different theories were just developed, and eventually that supports the existence of the quantum mechanics. And then, as we know, the Einstein called it as a photoelectric effect, and simply Einstein owned or secured Nobel Prize for the photoelectric effect, not for the his famous equation E is equal to mc square. So maximum people think he secured Nobel Prize for E is equal to mc square, but it is not true. So that is what we can see how the quantum mechanics were developed step by step. Then after like a photoelectric effect, there was a explanation, or the explanation given by the Compton. And again, Compton supports like simply how the scattering can be occurred. And if any of the light or any of the radiations like gamma radiations interact with any of the object, then what may happen, then it may get scattered, and the scattering wavelength or the scattering beam must be having the highest wavelength rather than the incident one, and then they call it as a Compton shift. And then they can develop, they can just explain like a Compton shift as with the help of h upon m naught c, 1 minus cos of phi. So likewise, like a lambda dash minus lambda, they called it delta lambda. So in that way, they have developed, they have explained the Compton shift also. And then again, with the help of that, means there was a evidences, there was a like evidences for scattering in terms of the quantum mechanics, and again that gives very solid evidences for the existence of quantum mechanics. Again, if we see another problems like what cause spectra of atoms to contain discrete lines, as I have discussed the spectra obtained from the black body radiation having the discreteness, and discreteness can be studied with the help of discreteness can be studied with the help of some spectra. And again, you can see it was apparent that only a small set of optical frequencies wavelength could be emitted or absorbed by the atoms, and then each atom has a distinct fingerprint, as we know, everybody knows, and that can be proved with the help of X-ray diffraction. And then light only comes off at a very specific wavelength or the frequencies or the energies. So again, that we know, and that is what the electromagnetic spectrum. And again, that gives some explanation how every radiation is differ from each other. And if we go for, like as we know, towards the gamma radiations, then we can see, or we can have a particle nature more prominent, whereas if we go towards the radio waves, then there is a existence of the wave nature. So in that way, if we are coming in between that, where we call it as a visible region, then we can see the particle as well as wave nature, and that is existed over there. So simply again, we can see without quantum mechanics, we could never have design and build like a semiconductor devices as we are using computers, cell phones, because quantum mechanics gave that. Simply in last lecture also I have discussed like the equation, famous equation, like En is equal to n square h square upon 8 ml square, and this is the equation comes out from the one dimensional potential well, and with the help of that we can calculate the energy levels. And again, that energy level gives us the splitting of the energy levels, and eventually there is a formation of the band. And again, as we know, the band gap, it's a very much important concept whenever we are trying to modulate or prepare any of the devices, maybe semiconductor devices or the dielectric material or the ceramic material or any of the material. So we are just trying to discuss about the band gap, and again, depending upon the band gap, we can have the behavior of any of the material. So that means it is very much difficult if we don't have the quantum mechanics, and that is why we can just thanks to quantum mechanics for having such type of beautiful explanation. Some of the like practical applications you may be knowing, like DVD players, CD players, then the barcode scanners, or some of the MRI, as you may be knowing, magnetic resonance imaging, then nuclear reactors, atomic clocks. So these all are the beautiful applications that we can solve or we can explain with the help of quantum mechanics. So quantum mechanics gives lots of support or lots of the explanation for these all. So again, physicists didn't embrace quantum mechanics because it was generally novel or the weird, and that is why means there were so many assumptions, why and why we should accept this mechanics as it is, why means why this theory can exist, why this means why do we accept it, and then there were some exist like evidences. And again, simply let me tell you the means the biggest breakthrough in quantum mechanics was the Planck's constant. And if there is no Planck's constant, then we know how we can prove the E is directly proportional to nu. Nu is the frequency, E is the energy, and then Planck's constants came into the picture. That gives us the E is equal to h nu, and that can prove or that can give us the very beautiful explanation. And again, we know from this particular equation we can generate lot of devices, although this h has a very small value. Then like unification in physics was also started by various scientists, and then they just try to work together for the unification and all like that. Again, as we know, the end of the mechanical age, but still we can't say there is a end of mechanical age. Still it is there. Still classical theories or all the classical theories are still relevant. But again, only thing is that means thing is that ki whether we are studying the microparticle or the macroparticle, and accordingly we have to think, or we have to apply the mechanics. So simply the things moves in continuous manner, all motion both in the large and small, so exhibits continuity as we know. So things moves for reasons, all motions have a history, is determinable and predictable. So simply yes, we can. The universe and all its constituent can be understood as complex machinery, each component moving simply. So as we know, if we are talking about universe, then how many planets are there, how many galaxies are there, and all like that, and how they are connected with each other. Then that phenomenon we means is really beautiful, and beautiful to study and explain, but at the same time it is too much complex to understand. So that again means like quantum mechanics helps to understand how they are interconnected, how they are moving, how what can be happened and all like that. So a careful observer can observe the physical phenomena without disturbing them, as we know. So inside atoms, he is simply this one. The careful observer can observe physical phenomena without disturbing them. So simply because of quantum mechanics, we have some devices. As you may be knowing, scanning electron microscopy, we can read the surface, we can scan the surface, we can gain the information which is available on surface, or we can gain the information about the cracks in any of the material without disturbing that material. So these all concepts are possible only because of the quantum mechanics. Then inside atoms, all of these attempts proved, as we know, the false and all. So just because of these all reasons, now what went wrong, we can see classical physics could not explain the line spectra. So just I am concluding. Line spectra means the spectrum obtained from the black body radiations, or some simple line spectra also. Then the electron configuration in atoms, like a black body radiation, photoelectric effect, a specific thermal capacity of a crystalline solid, Compton scattering of X-rays. So these are the major theories, or the major theories which could not explained by the classical physics. So you must remember there may be some MCQ type questions on these particular lines. So can we explain these type of the theories with the help of classical mechanics, or anyway the questions must be from this type of the clues. So be prepared for this. Then, like if we go for quantum theory, then as we know the quantum mechanics, so electrons in atoms, that is simply chemistry, or the superconductors, or the laser or semiconductor electronics. So as we know, so we can have the explanation of these all electrons in atoms. So means like how electron is move like revolving around the atom, around the nucleus in any of the atoms. So that can be again explained with the help of quantum mechanics, and that was supported by, as you may be knowing, everyone knows, the theory of atom was given by like a Neil Bohr, Bohr's atomic model. But again, that was confirmed by Heisenberg's uncertainty principle, that electron cannot reside inside the nucleus, which means that electron must be moving around the nucleus. So this is quantum field theory. Like we can see the interactions mediated by messenger particle, then like quantum electrodynamics, wherein interaction of light and matter, so interaction of charged particles, annihilation of pair production. So these all simple explanation, not simple, we can say the complex explanation, can be again given by, or can be explained by the quantum field theory. Then electroweak unification, weak force plus electromagnetism, or the quantum chromodynamics, like quarks and gluons. So as we know, there are certain particles which are present inside the nucleus. As simply as a layman we are saying, if we are talking about nucleus, then only there is a proton and neutron. But again, there are certain particles, or the subatomic particles, which are present inside the nucleus, and that explain everything except the gravity. So that is why the quantum field theory or the quantum theory or the quantum mechanics are really helpful to understand or to explain these all phenomena. And that is why here we are discussing the quantum mechanics in detail. So again, simply as we know, so these are the things. So again, the quantum theory in essence, as we know, so the entity is like system with discrete states, as I already explained. The discrete states means if we see the black body spectrum, then it is not continuous. It is a discontinuous. So then again, physically observable quantities like events. So that can how we can explain all. Only the probability of events is predictable. Then again, whatever happens in between emission and absorption. So simply if we go for like any of the like a we call say the photoluminescence or any of the luminescence kind of the phenomenon, then there is a emission and absorption of light. So light is always emitted and absorbed in discrete amount of energies. Then how much light will be absorbed by any of the material, then how much light will be emitted. And again, we know as on the basis of this particular phenomenon, we can have the light of different color. But again, if we want to explain this all phenomena, then we need a base of quantum mechanics. Without the quantum mechanical base, then we cannot understand all these phenomena. So again, Einstein said कि God does not play dice. Einstein said कि God does not play dice. So simply, yeah, these are a really beautiful statement, and that we can understand very deeply why Einstein said like that. Then Feynman said things on a small scale behave nothing like things on a large scale. So I hope you can accept nature as she is absurd. So again, Bohr said, anyone who is not shocked by quantum theory has not fully understood it. So even though we the student of physics, we the student of quantum mechanics, we shocked, always trying to understand how exactly this physics works. So that is why like these three statements are really heart touching to me when we discuss or when we just trying to understand quantum mechanics. So friends, as we know, simply you can see the images over here. If we are having 3 into 10 to the power 3 photons, like 1.2 into 10 to the power 4 photons. So here you can see how the clarity will be there. And again, the clarity will be always depending upon the resolutions, and that kind of the resolutions have achieved with the help of the microscopy, like electron microscopy or like a scanning tunneling electron microscopy, where we can observe the surface of any of the material. So like a photon seems to obey the command like explore all path, all the possibilities can be added up in a special way and used to predict what happens. So again, particle physics, the same approach is used to work out how quantum particles change into one another, like a neutron or decays to like a proton, and simply you can see interact with one another. Electrons repel by exchanging a photon. So how the interaction between the electron and photon will be there, so that we can say the collisions and how like after collision what will happen. So that phenomenon also can be explained with the help of quantum mechanics. Then again, scientists agree to differ, like agreed formalism or the different interpretation, like does the quantum world really exist, or is there only abstract quantum physical description? So that is really deeper to understand or deeper to know. And the responses include like you can see Copenhagen interpretation. There is no objective reality. A quantum system has no properties until they are measured. Yes. And again, many worlds, all things happen in a branching universe. The non-local or the hidden variables, an attempt to restore realism. So these are the responses came from the different philosophers or the different thinkers or the different learner, and deeply we can understand number of things from that. So again, if we see the line spectra, then in line spectra we can see here there is a ladder of energy level in the atom, and now you can see how it will be explained, like simply you can understand from this particular model. And here, as we know, if we are trying to understand the hydrogen energy level diagram, then we know there are different series, like a Lemon series, then the Balmer series. So and again how electron will be. So and how the energy levels will be like separated or the split from each other. So that can be again, as we know, the difference h nu or hf is equal to hc by lambda, where this c is the velocity of light or the speed of the light, and h is the Planck's constant. So with the help of that also, means we can understand the spectra, and that gives us the qualitative explanation for the existence of discreteness in a spectra. So if we see here, you can see that spectra is not continuous. So here there is a discreteness found. So that can be explained with the help of quantum mechanics. Then like probability waves for electrons. So here you can see the STM scanning tunneling microscope image. So electron density waves in coral of 48 iron atoms on a copper surface. Now you can see. So if we are depositing iron atoms on a copper surface, you can see how they will be looking like that. And that can be only possible with the help of scanning tunneling electron microscopy or the scanning tunneling microscopy. Otherwise it is very much difficult to understand how they are aligned with each other, how they are bonded with each other. And really that means if we don't have quantum mechanics, then we could not have explained this all. Again, if we are talking about molecular spectra, so you can see molecules to absorb and emit the photons of characteristic energy or the frequency by changing their vibrational modes. So simply if we see any of the spectroscopy, then we know what we are changing. We are trying to alter their vibrational modes. Even though, as we know, when we go for any of the spectroscopy, then we are trying, if we are just trying to dope some impurities, then we are trying to understand, we are trying to explain what is the effect of impurity on that material. So you can see here spectroscopy, so to monitor like a car exhaust, or to find the rotation rate of stars, or to analyze pigments in a painting. Yes, to identify forensic substances, to map a patient's internal organs. Then again, we can understand the greenhouse effect also. So, in that way, we can say or we can understand how quantum mechanics is important, and how many things can be explained with the help of quantum mechanics. So, that is why quantum mechanics is really important. Then simply we are just concluding towards what we learn. So as we know, you can see the photoelectric effect. If you want to understand, then we know when light falls, light means it is having the quanta of photons or the bunch of photons. When it falls on any of the metal surfaces, then there is a ejection of an electron. So that simply we can understand from this particular figure. And there is a particular frequency after that it is very much difficult to eject the electron. So that simply we can understand from this particular figure. So threshold frequency, after that it is very much difficult to eject the electron. Okay, so let us move. Here we can see the photoelectric effect. So energy of incident photon is equal to, as we know, h nu. And again, with the help of this, we can have some explanations. And as we know, so simply the photon's energy can do the things like enable an electron to escape the metal surfaces, and that function, as we call it, as a work function. And that work function gives the free electron. We know the free electron ek, and that can be hf, or the h nu is equal to 5 plus ek max. And that with the help of that we can explain. So from that we can calculate the photon flux also. So the photon flux, as we know, the calculated number of quanta of radiating being emitted by a light sources. Quanta means simply the like a wave packets. that we called as a quanta, and quanta is always emitted from the surface. So for that, you can just means how much photon flux. So to calculate this, it's very much important, and that problem, this problem is from one of the NET examination. Like consider a green 100-watt lamp. For green light, the wavelength is about 6 into 10 to the power minus 7 meter, and so. So the energy of photon that can be calculated as E is equal to HF, and simply the frequency can be denoted as Hc upon lambda, and the energy comes out to be 3.3 into 10 to the power minus 19 joule, and the number of quanta emitted per second by the light is n upon simply n is equal to 100 joule per second upon this value 3.3 into 10 to the power minus 19 joule. So that comes out to be 3 into 10 to the power 20 per second. Like again, if we see the photons generated or the photons from LEDs, so energy of the electrons releases a visible photons from the semiconducting material. So where we know the EV is equal to HF is equal to Hc by lambda. So with the help of that, we can solve. So again, here we can see the electron diffraction. So as we know, we can have the diffraction with the help of X-rays. Likewise, electron can also diffract, and because of the diffraction of an electron, so we can prove the equation lambda is equal to hp, which proves us the matter waves, or there is a means wave associated with the particle, and the particle nature associated with the wave nature. And for that, you can see here this electron diffraction, how it helps. So here you can see the diffracted beam. So here, so E is simply we can see, we can understand. Even the D, we can see how the beams are split. Even the C also, but here it will be difficult. So in that way we have to resolve. So that can be the double slit experiment with increasing number of electrons. So if the number of electrons are increased, then you can see how the pattern will be generated. So you may be knowing this pattern is just like means the simply dark, and just you can see the light pattern is here. Again, quantum behavior, so not particle behavior, not wave behavior. So that again, that can be evidence by number of experiments, like Young's double slit experiment that proves the wave nature of light, whereas the various quantum mechanical experiment like photoelectric effect, Compton effect, that proves the particle nature of the light. So, like some of the questions we can see, like quantum is what, or the photoelectric effect, and de Broglie and all like that. Again, another question arises always: how and why the nucleus is stable. But as we know, if we go for the radioactive material, then as we know the how disintegration of the material will be takes place. But some of the nucleus are very much stable. So you can see like carbon 12 is stable, carbon 14 is radioactive. So decaying to nitrogen 14. So why and how it is happening? So again, that explanation can also be given by the quantum mechanics. Then if we go for the reason for this, then we need to understand how nuclei are basically builded. So where we can see the discrete energy levels inside the nucleus. So fermions are particles that cannot share the same quantum state. So they obey the Pauli exclusion principle. Like protons and neutrons are both are fermions. So simply we can go for, as you may be knowing, if we go for different statistics like FD, Fermi Dirac statistics, then we can explain the behavior of these particles like a protons or like a fermions and all. So that again gives some explanation, means support, or the support to statistical mechanics. And the scientists like Fermi Dirac or the Bose-Einstein, they were able to explain the behavior of microparticle when we are moving towards a very complex system. And that is why again quantum mechanics plays a very vital role. Then again, the stability of any of the nucleus is always depending upon its energy. And again, on the basis of that also, simply as we know, the Einstein gave one of the famous equation, E is equal to mc square. And again, here we can see the binding energy per nucleon curve. So how they have calculated, and with the help of that, how do we get the answer for this? Then again, here we can see the quantum tunneling. So in case of quantum tunneling, how particle behaves. So basically, you may be knowing the tunnel effect. So if we go for tunnel effect, then how particle behaves basically. As I have mentioned, and tunnel effect is nothing but the tunnel effect can be explained with the help of the Schrodinger's equation. So Schrodinger equation helps us to explain tunnel effect very beautifully. So simply you can see the potential barrier is there, and again the energy of the particle is less than that the barrier. Then how that particular barrier can penetrate or cross that barrier? So by penetrating, here you can see the alpha particles. So this is what the potential barrier around the uranium nucleus presented to an alpha particle. The central veil is due to an average nuclear attraction of all the nucleus, and the heel is due to the electric repulsion of the protons. Alpha particles with energy E trapped inside the nuclear veil may still escape to become alpha rays by quantum mechanically tunneling through the barrier. So simply instead of crossing this particular barrier, alpha particle may tunnel or cross the barrier with the effect of tunneling. So simply another applications for better understanding like a PET scans, positron emission tomography. So as you may be knowing, so that is again one of the application of the quantum mechanics. So without quantum mechanics, we cannot explain this. And here you can see matter and antimatter. So that is also explained with the help of some quantum mechanical theories. Again, we can move towards the particle physics from quantum mechanics, where we can understand about the electron, neutrino, then muon neutrino, tau neutrino, and again we can have different quarks, how they are charged, how they are rest energy, and all. So simply we can see some of the families of particle, like you may be doing hadrons made up of the quarks, then the baryons. So this is again the part of nuclear physics, but again we cannot explain it without the help of quantum mechanics. So that also how the disintegration will be takes place, how the beta decay will be there. So that can be explained with the help of the quantum mechanics. So like a gluon mediating quark interactions. And simply finally, when we are coming to all types of the interactions, then we know the electromagnetism or the weak interaction, strong interaction, and the gravitational force. Means the four forces are there, and that forces how they carry and how the charges would be there. And again that can be explained with the help of which kind of the theories. So simply again we are coming towards the application of the quantum mechanics. We'll see some numericals or the MCQ in next class basically. Like we know, when we talk about any of the atom, then how small it is, how small it may be. So then scientists, or like from the Richard Feynman, so many scientists tried to understand the smallest particle at a nanoscale, 10 to the power minus 9 meters. And then they found there is changes in their properties drastically if we come down the size of any of the material. So that also happens. And here you can see how do we see the scale. And like simply you can see galaxy 2 here, some of the small particles which cannot observed by the naked eyes. So that for that we require the electron microscope. Here you can see cell or the DNA, atom, nucleus. So in that way we are moving. Then again, the waves and particles, what do we mean by by them? So simply, as we know, the materials means simply if there is a wave, then there is a particle, and if there is a particle, then there is a waves. And waves is nothing but a disturbance in a medium. But that oscillations or the disturbance can also explain with the help of the quantum mechanics. So simply particle and waves, so their basic difference is in their behavior. As we know how the wave is behaving, here simply as we know how uniformly it is behaving. Whereas you can see the particle, they may have the random direction, they may have the random orientations and all. So when particle collides, they cannot pass through each other. They can bounce or they can shatter basically. But here you can see if the waves are colliding, then how it may have the like a transmission or it may have the reflection. And again, accordingly, we can study the phenomenon of the waves. So simply we can see here if there is a collision, and so in that case what will happen depending upon their energy, as we know. So how they will be moving further. But here you can see if two waves are collide, or collide or just meet at one point, then what will happen? So as we know, their intensity will be, or the amplitude will be increasing, simply we can see. So waves can pass through each other. As they pass through each other, they can enhance or cancel each other. They can enhance. Enhance means they can increase. There is an increment in amplitude, or they can cancel each other. So later they regain their original form. So simply we can understand about the waves and particle. So like again, if we see the wave nature, then the spread in space and time so can be superposed or the show interference effect. So pass through each other. So you can see here. So in the 20th century, as we know, the study of atomic systems required a fundamental revision of this classical idea about the physical objects. And then again, as we know, as I told you, so this is a very important like a concept in quantum mechanics. So this quantum picture of the world is at odds with our common sense view of physical objects. So we cannot uniquely define what is particle and what is wave. But again, as we know, if we go towards this, like Neil Bohr and Werner Heisenberg, were the architects of this quantum world view. So, along with Planck, Einstein, de Broglie, Schrodinger, Pauli, and Dirac. So, as you may be knowing, we'll be discussing the Dirac's notation and the Dirac matrices and all. So really, they have given the integration of classical mechanics with the quantum mechanics, and that gives the evidences of the existence of the quantum mechanics. So, and for that we know, or they know, or they have given the true understanding of nature is required. So that like physical objects, whatever they are, neither exclusively particles or the waves. So, but the no experiment can ever measure both aspects at the same time. So we never see a mixture of particle and wave. So as we said, कि we never say. So as the famous equation is lambda is equal to h by mv. अगर वेव नेचर बहुत ज्यादा डोमिनेट करता है तो पार्टिकल नेचर डोमिनेट नहीं करेगा, और अगर पार्टिकल नेचर डोमिनेट करता है तो वेव नेचर नहीं मिलेगा. So that simply we can understand, and the object is described by the mathematical functions which are measures of probability, everyone knows, and that is why we can say that the quantum mechanics is the probabilistic mechanics. Then we can see here some of the milestones of the quantum mechanics, like electric current, flow of electrons, and then simply how electrons moving from the discharge tube. And again, as we know, if we want to see the electron, then we can see with the help of the fluorescent screen, like simple devices which are available in our laboratory, like a CRO, cathode ray oscilloscope, or the DSO. So with the help of that we can see. So another thing is that the quantum of light, or the photon. So particles of light are called the light quanta or the photons. As we know, the Einstein again gave more explanation. So packets of energy in photon is so small so that we are not aware of the rain of photons of light impinging on our eyes. So just as you cannot feel the impact of individual air molecules, you only feel a breeze. So as we know, so likewise we cannot see the how many particles or how many particles are there. But again, Rutherford and Neil and his nuclear atom, so like from 1898 to 1911. But after that, Neil Bohr has given the satisfactory explanation, and that was supported by the Heisenberg's uncertainty principle. So we can see here the again the Bohr's atomic model. So that we know they have combined the concepts, like, so understanding the origin of Bohr's model required an essential bold step, like that was given by the Louis de Broglie. So simply wave nature of matter. So that can be understood with the help of the electron microscopy. So here we can see the picture of fly with the help of electron microscopy, how beautifully we can see the fly. So that much resolution is possible with the help of electron microscopy. So let us conclude with the summary of duality of nature, like wave particle duality for physics. So light and particle, so that can be explained by the photoelectric effect. So matter use electron microscope of the electron current photon collisions and all. So discreteness also explained. So let us conclude the quantum mechanics. Like all physics objects exhibits both particle and wave-like properties. This was the starting point of quantum mechanics, developed independently by Werner Heisenberg and Erwin Schrödinger. And again, that is what the conclusion of today's class. Then the particle properties of the waves can be explained with the help of Einstein relation, like E is equal to h nu. Again, the wave properties of the particles can be explained with the help of de Broglie's relation lambda is equal to h by mv. And the physical objects described by mathematical function called the wave function, that is defined by the psi or denoted by the psi. So that can be also explained here. We can see how the wave is moving, and this is basically wave function. Means if there are number of waves, then we cannot say that how they are moving. So they are merging with each other, or as we have seen earlier. So but they have, we can define them with the help of the wave functions. So like spread in positions, we can see the superposition of waves of the different wavelength to make a wave packet. So this is the wave packet which is moving here. So now we can see the illustration of measurement of the electron position. So that can be measured with the help of the like you can see here how electron position can be measured. So here the photon, you can see how it will be impinging, and here we can see it will get scattered, and where we can measure the electron position. So simply this is what today just we want to discuss about the quantum mechanics. So at the end I want to conclude here with some of the statement. You can see a common sense view of the world is an approximation of the underlying basic quantum description of our physical world. So in the Copenhagen interpretation of the Bohr and Heisenberg, it is impossible in principle for our world to be deterministic. So Einstein, a founder of quantum mechanics, was uncomfortable with this interpretation, and that is why. So Einstein thought along with number of scientists, and then they have given different explanations about the quantum mechanics. So this is what the general idea about the quantum mechanics, which must be helpful to solve the bigger problems. But to solve any of the problems with the help of mathematical expression, or like a matrix mechanics or the wave mechanics, we must understand the basic of quantum mechanics. And that is why we have devoted a number of lectures to understand the basics behind the quantum mechanics. So here just I want to stop for today, and at the outset I thanks Rajiv Gandhi sir for giving me an opportunity to share my views, my knowledge, my ideas on quantum mechanics. So thank you, Bharti. Thank you, Rajiv sir, for giving me an opportunity. But at the end, before concluding this session, I just want to give you the list of the books which you can refer. You can refer the Quantum Mechanics by Gutta, Quantum Mechanics by Sheep, Quantum Mechanics by Arul Das, or the Quantum Mechanics by Merce Baker. So these are the 4 or 5 books are really difficult to understand, but gives you the sound explanation for whatever you want to understand about quantum mechanics. Even though another book is like Arthur Bezer's Applied Physics or Advanced Physics, in which the part of quantum mechanics is there. So friends, in that way, you can just try to understand the phenomenon, try to understand the basics behind this. So here just I want to stop for today. So again, once again, thank you, and I wish you all the best to all the participants. Thank you so much.